Hi guys, so today's our last lesson on probability, and today we're going to talk about the product rule. With the product rule, it makes life so much easier because we don't need to make a tree diagram or an area model anymore. So right now they want us to find the probability of choosing a white, black, probability of choosing a striped sock, then a white sock, probability of choosing a black sock, then a black sock, probability of white and white, probability of striped and striped. Now you might be sitting here going, that's a lot of problems, but they're very easy if we use the product rule. Now, if we didn't use the product rule, we would have to use a tree diagram where this tree diagram right here would represent, well, started to represent the probability of getting a black sock and then choosing another black sock. We would have to finish this tree diagram to answer that question, and we would have to create a completely different tree diagram in order to do the probability of choosing a white sock, then a white sock, striped, then striped, white, then black, and then striped and white, which I will fully admit is a lot of work. Same thing with an area model. This is the area model we would use in order to figure out the probability of choosing a black sock first and then our second pick. Again, this took me a while to create, and that's just not realistic. But if we use multiplication, we can actually figure out these probabilities very easily. So to start out, you need to find the probability of finding a certain sock. So like, for example, the probability of finding a white sock, we would do 4, because there are 4 white socks, and put that over 12, because there are 12 total socks in this drawer. Then we would find the probability of black. We would have 5 black socks in the total of 12, and then 3 striped out of the 12 total socks. So in the long run, there's 132 possible outcomes for this problem. And that's a lot. But like I said, using that product rule, this is actually going to be very easy. So I'm going to take the probability of choosing a white sock first, which is 4/12, and I'm going to multiply that by the probability of choosing a black sock. But hang on. If we choose a white sock, there's no longer 12 total socks. There's 11 total socks now, 5 of which are black. So if we multiply the 4 times 5, we get 20. When we're multiplying our fractions, we want to multiply across the top and across the bottom. So we do 12 times 11 and get 132. Now, we can simplify this fraction, or we can just turn it into a decimal by taking our top number and dividing it by our bottom number. So we get 0.15 repeating, which if we times that by 100 in order to turn it to a percent, we get approximately 15%. So we have a 15% chance that we will choose a white sock first and then a black sock. To walk through another example, the probability of finding a striped sock is 3/12 times a white sock. Now remember, we took a sock out, so there's only 11 socks left, 4 of which are white. We multiply our numbers across, so we get 12 over 132. Do our top divided by bottom. So 12 divided by 132 to get 0.09 repeating. Then we times that number by 100, and we get approximately 9%. So we have a 9% chance of getting a striped than a white. All right, I'm going to do one more with you guys, and then I'm going to ask you guys to pause. So we're going to do probability of choosing a black sock, which is 5/12. And then we're going to times that by the probability of choosing a second black sock. Now, yes, the probability was 5/12 for this one, but if we take a black sock out, there's only 4 more black socks left for us to choose from out of 11 total socks. So make sure you dock one on that second one. So if we multiply across, we're going to get 20 over 132, which we already know from up here is 0.15 repeating from our first example, and is approximately 15%. So we have a 15% chance of getting a match with black socks. All right. Now it's your turn. So go ahead and pause this video. I want you to try to find the probability of choosing 2 white socks, and then the probability of finding 2 striped socks. And then go ahead and press play once you do that and see if you get the correct answers. All right, let's see if you guys got the correct answers. So the probability of choosing a white sock is 4/12. Now, if we took one out, we go down to 3. And if we take a total sock out, we go down to 11. So we get 12 over 132, which we know from our second example is equal to 0.09 repeating, which is approximately 9%. So hopefully you got 9% chance of choosing a white sock. And then when we use the striped sock, we're going to do 3/12 times 2/11 because we took a striped sock out. And then we get 6 over 132. So we have to take our top divided by our bottom, and we get 0.045, where the 4 and the 5 repeats. So I'm going to make sure that bar goes over the 4 and the 5 and not the 0. And then if I times that by 100, we get approximately 5%, or you could say approximately 4.5%. Either one would be fine for this case. So we definitely have a lot smaller chance of getting this 2 striped socks in a row. So hopefully the product rule makes finding compound probability a lot easier. Just note, for example, if I was flipping a coin, we have a heads or a tails, and let's say I was rolling a number cube, our probabilities don't change with these because we're not taking something out. The example we did today with the socks is called dependent, where the second event depended on the first event. If we have like a coin and a number cube and they have nothing to do with each other, that's independent. So for example, if I wanted to find the probability of getting a prime, so I'm actually going to write it like the ones before. So probability of getting a prime number on a number cube and a heads, for example, I would say the probability of getting a prime number on a number cube is 3/6, because there's more prime numbers than 3. So our prime numbers, sometimes it's good to list these on a number cube, would be 1, 2, 3, 5. So there's 4 prime numbers out of 6 total numbers on a number cube. And we're going to multiply that by the chance of getting a heads on a coin, which is 1/2. And we would get 4/12, which is 1/3. So it is 0.3 repeating. Or if we times that by 100, we would get approximately a 33% chance of getting a prime number and then a heads. This second probability didn't change because flipping a heads has nothing to do with getting a prime number on a number cube. So just make sure you're careful on whether you're dealing with independent or dependent events.